Okay, today I'm going to teach you guys about ground tracks and the satellite Earth cam and the orbit of the ISS. So, materials we're going to need for this is you're going to need a Sharpie, you're going to want a Coke can, any can honestly, a rubber band. You can get a hair tie from your mom's closet or ask her for one. Pair of scissors. Be careful. We need to cut tape. And this printout, which will be in PDF version. And I believe I will link this PDF, and I will also link the student guide to help you guys out in constructing this. But in this video, I'm going to cover how to construct it, so that shouldn't be a problem. So yeah, that's what we need. You're going to want about 4 to 5 of these little pieces of tape, just little strips, because they're going to help you keep your rubber band when we're creating the orbit of the ISS. And you're going to want, mine is pre-tape, but you're going to want 2 little pieces right here. As you can see, mine is a little off of this black border that you see on this edge, which I created because when you put it around the Coke can, it actually didn't fit. So I just kind of custom cut it to make it fit. You don't have to do that. You could do to the black line. It'll just look kind of funky and your line won't finish. It'll still look fine once you lay it out though, because I already tried it. So what we're creating today is the orbit track of the ISS, and why when you see on your camera, or when you come to JFK next year on your camera, why it says United States, Australia, Africa, over the Pacific, the Red Sea, and why it has those locations. And that's because of this orbit that you're seeing here. If you're tracking along here, all these locations that it passes. So this Earth cam, it's called the satellite Earth cam, is going to obviously label and tell you where the ISS is at currently. I labeled this out, this little teacher guide. It's the northeast, south, and west, to help you guys out in figuring out what direction the ISS is actually traveling around the globe. And it actually is traveling east, which I didn't know and was a surprising fact. Let me get these materials out of the way. I'm only gonna need this and this. So this paper is going to talk about, this is the PDF I'll be actually letting you guys have, which is it'll help you build what I'm constructing on this video. And the northeast, southwest, that's what I talked about. North pole, your south pole, east and west, which creates your equator. The ISS orbit has a orbital inclination, and that's why the orbit of the ISS looks like a sine wave. It's like a roller coaster. It has a very special orbit. If it was on the equator or on north to south, we'd be having a different story. So to find out distances and where the Earth cam's going to be, all these NASA scientists needed a way to simplify it for me and you guys to understand. So that's what we're going to be doing today. So I'm going to read these little paragraphs up here for you guys, just to kind of brief out what I'm going to be teaching today. So to know where the satellite Earth cam can capture images, you need to know where the ISS travels in its orbits around Earth, the International Space Station. The path on Earth's surface that lies directly below the space station's orbit is called its ground track, which basically means I'm staring at the ISS at night, and that means I'm tracking it. So it's ground tracks. Kind of straightforward. The ISS does not orbit directly around the equator or around pole to pole, which is what I just talked about. It has that incline. It's very special. The angle of the station's orbit in relation to the equator is its orbital inclination. The angle of the station's orbit, the point where the space station's orbit crosses the equator on the way up, is called its ascending node. So this is the ascending. It's going up. To the point where it crosses the equator on its way down is the descending node. So this one doesn't show the descending node, but this one does. So this is showing its ascending node. So this is when it's traveling up on the globe. And then this is when it's going down. So it's just a big circle, basically. So yeah, that's what we're doing. I know you guys are probably antsy. Let's get this thing going, right? So this was just like a little template to help you guys out. So let's start building now. So what you want to do is get your can. Make sure it's empty, of course. Before I filmed this video, I actually spilled Coke all over my table, so I had to clean it. So you're going to want to get your paper. I suggest finding a little line. I actually see like a little line on this Coke can, so I'm going to line my paper up right on that line. And seems good enough right there. And don't do what I did. You see how I just stuck it like that? Make sure only one side is stuck. So when you get your other side, you can kind of lift it and maneuver it. And you're going to want your equator line to line up. That is your equator. This is what splits the north from the south. Throw that down there. You're going to get your can right there. Make sure this is nice and snug. And the reason I did this is because you're going to have your orbit going across right here. So you don't want any tape just going straight down, because the minute you pull this tape off, you're actually going to lose that line you just created, which will kind of suck. So what you're going to do is you're going to get your rubber band, and on the instructions, it wants it nice and flat on your paper. On the equator. See how notice how I put it right on the equator. And the reason I did this is because there's a point here, C, and there's a point here, A. So we already have those points covered. Boom, boom. And this is where those little pieces of tape I told you to cut out are going to come in really nice. So these are designed to hold your rubber band down. This will kind of mess up your line, but once you create your line, you can kind of just fill this line in. Not a big deal. So you're going to put one there, and then you're going to put one on A. Make sure that's down. Make sure you do it one side at a time. So I got my nail in there, pushed it down, and then you want to get this side. Don't do what I just did. So you put your nail in there, get it nice and snug on that paper, because this will just like, this tape will just pop off. So now I'm going up to point B, which is now creating my sine wave. See that? That is called a sine wave. And this is created because of the orbital inflation. Oh, messed that one up. Let me move it up more. Make sure you get your nail in there to hold it, so when you're taping the other side down. And I'd suggest getting that tape right on there, right on your actual metal, because if you don't have it up there, it's going to be really tough and it'll move on you. Okay, one more piece. Finish this one side. Make sure you get your nail on there. Get that metal right there. Nice metal. There we go. We have now. Then I'm just straightening these lines out, so when I go and trace it, looks very nice. There you go. That is your can, fully wrapped in a rubber band. Following the orbit, this is the actual orbit of the ISS. Notice Colorado's right here, so it actually almost passes directly over our state. So now you're going to want to get your marker. I'm using a Sharpie. You can use a pencil, whatever you have in your house. And you're just going to start wherever you want. Essentially, this is your choice. So I'm just going to follow the top of the rubber band. I'm going to trace over the tape. And then just going over. So once you traced it all, now you can put the cap on your Sharpie. Don't mark your table. Then you're going to take off all your tape. Be careful with this because you can rip your paper. I just ripped some of my paper. All right. Be careful. You can tell I am not being patient. Here we go. I believe that's all the tape. Like, slide your rubber band off. Boom, rubber band's off. Now you want to get this tape right here. Be careful, don't rip your map. Pull it up. Pull it up, pull it up. There you go. Boom. Whoa, what the heck, dude? What'd you just have us make? Yeah, I know it looks like a bunch of straight lines. But now what you're going to want to do is you're going to want to fold this tape, take it off, whatever is your preference. I'm just going to fold it for time's sake. And you're going to want to pass through this point or above it. The curve will be above it just because our line was traced above it. So it won't be precise to say. It won't be as precise as this map. So actually, I'm going to open this map so you guys can see this one. This is the actual map that they gave me as the teacher guide. So this one is extremely nice. So as you can see, depending on your rubber band job, you can get this outcome. Unfortunately, I got this outcome. Same thing. And you always want to remember, we're moving east. So remember, never eat soggy waffles. So which way are we going? East. Arrows are all east. There you go. Looks just like that one, doesn't it? All right. So that's kind of crazy, right? We went from looking at this to looking at this. It shouldn't really blow your mind though. And here's why. So once I wrap this paper back together, boom, there's those lines. There's that circle. Boom. That's creating the shape. This is the actual shape of the Earth split in half. And that's what the ISS orbit path is. And this is where you can ground track the ISS orbit. So we actually wanted to do this with you guys in person. Unfortunately, due to COVID-19 and how the virus has unfortunately not been going so well, so we weren't able to do this with you guys. We really wanted to. I was looking forward to doing this. But we're actually able to do it for you guys virtually. Something fun to do. Get your head out of any homework you have. Just turn on this video and go ahead and get educated about ISS orbits and sine waves and all these crazy new terms. Got the equator going here. You know, this is really cool stuff. You want to be an aerospace engineer, that's the future. Look it up. They're looking up to colonize the moon by 2040. I'm not joking you. NASA has that big plan. And Trump just released Space Force. You want to go to the military and you want to learn about space, aerospace, join Space Force. Once you graduate boot camp, I heard you can apply for Space Force. So this is all becoming very real, very fast. So if you guys want to be a part of the future and you want to be written down in the history books for future space travel, I suggest you guys have fun with this and you do it if you think it's fun. Honestly, any engineering pathway can get into the space. Electrical engineering can create circuits for this stuff. A civil engineer obviously needs to help them with the structural stuff. That's a structural engineer as well. A civil engineer, the construction, they need to create the launch pads and stuff like that. So how much asphalt, how much concrete? You know, there's a lot of engineering pathways that all work together and they all get this done. They all fight for money. They all fight for contracts. A lot of AutoCAD drawing. A lot of math, obviously, to figure out these lines. that we simplify for you guys to understand. And you know, this is the future that you guys are learning right now. And I'm really glad that JFK had this opportunity to be a space lab school celebrating 50 years of NASA and sending a man to the moon. And we're gonna colonize the moon. So this is the future. Be ready. I hope you guys had fun making these. I had fun making it. Not with the rubber band, of course, but you know, you can use rope as well. Rope would probably work even way better because it doesn't have as much tension as this rubber band does. So yeah, there's the tutorial. I hope you guys have fun. My name's Abraham. I'm the senior, and yeah, that's it.